I'm Dan Hounsel, Senior Editor with Trade Press Media Group. Today I'll be discussing geothermal technology in institutional and commercial facilities, specifically the implementation of ground source heat pump systems in 2 Baltimore schools that have delivered on the promises of geothermal technology, which taps into heat trapped in the earth to provide year-round efficient and sustainable heating and cooling. Baltimore City Public Schools includes 2 net zero energy buildings, Graceland Park O'Donnell Heights Elementary School and Holabird Academy, identical 94,000 square foot buildings that opened in 2020. Both schools feature decentralized geothermal water source heat pump systems with demand-controlled ventilation. Every classroom has a heat pump attached to the geothermal system, enabling local control. The systems have delivered on their promises of performance. The schools use 300% less energy per square foot than the average school, and they enable the district to avoid the equivalent of 195 metric tons of carbon monoxide annually. Cynthia Smith is Director of Facilities Design and Construction for Baltimore City Public Schools. Smith says the district's 2 geothermal water source heat pump systems use about 26 miles of geothermal piping. Similar systems are being installed at 2 additional schools in the district.
In regards to the high school that we have, there's approximately 200 wells at that one. That is a lead silver, and that's also a decentralized geothermal water source heat pump building. And that was just selected as the most energy efficient HVAC system that we could select for the building.
Among the planning and design challenges that geothermal systems present for installations serving institutional and commercial facilities is the need for adequate site space to accommodate the system's piping and wells. Smith says this issue can be especially challenging for installations in urban settings, where buildings often are surrounded by paved surfaces and other facilities.
So when we're looking at our energy efficient systems, when we look at sites that actually have some green space, it becomes, a number one option that we're looking at when we do that. So the high school, for example, had a great field opportunity to build under, to drill our wells under. So that's why it was chosen, because it was the most energy efficient system that we could choose.
Smith says the installation of geothermal systems also can present managers and design teams with challenges, including unknown or undetected materials, equipment, and structures lurking under the installation site.
So for these projects, it was typically normal installation issues, obstructions underground, for the most part. Things that we had to be drilled through. Whether that was rock or whether that was something else underground that we had to drill through to drill the well. Other than that, though, we've had pretty. The one we're installing right now actually had a whole foundation from an old building that we actually had to remove because it was just too much in the way. We had to dig down and remove that foundation system from that old building that was just left in the ground. But other than that, the installation has pretty much been, pretty smooth. The drilling through the ground has actually gone fairly easily.
As with any relatively new technology, the geothermal systems have presented challenges for the district, including the need for training in-house maintenance and operations teams.
We did not have anything geothermal before these buildings. So, there was absolutely a bringing up to speed for, anything with the pumps and the way that the well field is laid out and how the piping works, and, all of that needed to be, all trained and for all of our teams. And that includes both through the design and the construction of it. We were not familiar with them either when we first installed them. So we had to, figure that all out too. And then, of course, for the operations.
Despite the challenges, Smith says the geothermal systems have performed as the district hoped, and the projects have provided several lessons for the department and the district. One lesson is to conduct thorough site assessments during the design phase and prior to construction. The assessment helps system designers understand site characteristics, including soil composition, groundwater levels, and space availability, all of which affect the feasibility of the project and system efficiency. Smith also says the projects have driven home the importance of understanding all of the project's costs.
Conducting that thorough site assessment while you're in design and prior to construction, because if you don't know your soil compositions and your groundwater levels and the space availability, it can totally affect the feasibility and the efficiency of the systems, and whether or not they completely operate or not. Acknowledging long-term versus initial costs. Geothermal systems do tend to cost a little bit more upfront, but they're so energy efficient. That long-term savings on energy bills, as well as the maintenance because it is a lot less equipment to maintain. There are the pumps, but there's you don't have boilers and chillers and separate distribution systems to have to maintain.
Ultimately, Smith says the success of the Baltimore City Public Schools geothermal systems will be judged by the benefits they deliver to the facilities and their occupants.
But then, literally, it's also just acknowledging that it does improve efficiency of the building, and it does improve occupancy comfort and health to have an HVAC system that works correctly. So having something that's very efficient and easy to maintain and can save us money in the long term, and give us comfort and health benefits to our staff and students is a good thing.
I've been talking with Cynthia Smith, Director of Facilities Design and Construction for Baltimore City Public Schools, about the district's geothermal systems. I'm Dan Hounsel, and thanks for joining us.